Hello, hello, hello. Okay, so welcome, friends. I hope I'm audible to you. So let's begin today's session. So let me share my screen. Today's session. Yeah. So good evening, friends. Sorry. Uh, yeah. Good evening, one and all present here. I'm Karthik Jadhav, research scholar in the Department of WRDM IT Roorkee, and uh, as you know that since last 9 weeks we are meeting at each Friday at 6 p.m. to 8 p.m. and we are solving problems related to the soil science and technology subject. So in first half or first 1 hour, we are trying to summarize the session of that particular week, and after that we'll solve questions related to the each week content. So before we begin, let me quickly uh, tell you that if you have any query related to this subject, you can directly write me to the provided email ID by putting SST as subject. I will try to return this query, your query by 1 or 2 days. Also, I would like to request you to watch all the previous content I'm uploading here. This is the personal YouTube channel, so you can scan this QR code to get all the content that I have uploaded for past 9 weeks. Also, I'm uploading all the lecture materials in the PDF format in this Google Drive. I would like to request you to provide your valuable feedback for this problem solving session by clicking to this link. So I can get your feedback, positive feedback, or it is a constructive feedback. So that will help me to uh, improve this course further, and also that will also helpful for my uh, personal uh, personal building. Okay, so yeah, since last 9 week, as I've told that we are discussing about soil science and technology, starting from history and its classification, its name, then what are its property, like physical properties, chemical properties, biological properties, and then we will we will talk about soil physical properties like soil, specifically about soil silicate clays, as we know that it plays fundamental role or primary role in cation exchange capacity. Then we will also talk about various plant nutrients and assessing of that particular nutrient, specific nutrients through various techniques. And also we will talk about some important organic fertilizer or primary soil compost. Then in last week, let me quickly revise. So in week 9, we have started learning about uh, soil degradation or land degradation. So we have found that it is a very fundamental problem in current current date because of various issues due to the climate change, right? And also growing population that altering the land use land cover. So due to that, we found that there are problems like degrading land, and that ultimately due to the either some physical force, biological or chemical contamination, and generally then we have introduced erosion. So erosion is basically we can classify them as a geological erosion or accelerated erosion, and then also we have introduced about soil loss tolerance. So whatever erosion happening beyond some natural erosion that ultimately cause some imbalance in the nature. So soil loss tolerance value should be such that that the soil loss that is happening from particular area should remain, or the rate of soil loss should be less or equal to the natural soil loss formation. Okay, so we found that soil loss tolerance value for most of the United States region, or also for Indian condition, that it is around 11 milligram per hectare. And then various preventive measures for erosion. So and basically we have talked about water erosion primarily first, because it contributes more than 50 to 55% 5% of the total erosion process. And then some preventive measures so for erosion management, and that we have classified in two terms, that is a preventive measures and control measures. So preventive measures basically we focus on the how we can prevent the soil erosion. Okay, it means we are starting some activities at the field before erosion will happen. Okay, and then once it will happen, then what kind of control measures we can carry followed, that will become under control measures. So here I'm not going in details. I've already talked about it. And then, as I said, that in water erosion, one of the fundamental uh, compatibility model is USLA equation, that is universal soil loss equation. So that also we have covered in last week, and that the basic formula of soil loss equation, USLA equation, is RKLSCP. So there are various factors like there is rain related factor, soil related factor, and land management factors. Then we have identified certain limitation, like Usla equation is not taking up, like it's only predicting annual average soil loss. Then also it is accounting only sheet and reel erosion. It is not accounting gully and uh, sorry, it is only account yeah, okay, it is not account gully erosion. So for that the Roosle equation came into the picture. So Roosle is basically revised universal soil loss equation. So it integrates GIS feature into it, that is geographical uh, system, right? So that also take into account, or we can compute it using that software, GIS software. And then ultimately we uh, uh, talk about the wind erosion after talking of the water erosion. So in wind erosion we identified certain basic topics, like why wind erosion is happening, and which are the areas, like either it is an arid area or semi-arid regions, that that where the wind erosion happening. So primary reason for wind erosion, that also we have identified, then its mechanism in particular region, and basically it is related to the detachment, transformation, and deposition. That is the fundamental definition of erosion. And then also certain equations like Usle to predict the wind erosion. Then we have also covered the topics that how to prevent the wind erosion, also introduced tillage erosion, basically conservation tillage. And then we have discussed about the types of tillage in detail in last lecture. And then we introduced the soil organic pollutants and inorganic pollutants. So in last week, basically we have focused on soil organic pollutants. So we have generally classified them in five categories. So that is industrial xenobiotics, agricultural pollutants, emerging organic pollutants, petroleum and fuel-based pollutants, and natural organic pollutants. So various industrial xenobiotics like PCBs, that is polychlorinated biphenyls, polyatomic hydrocarbons, dioxins and furans, and chlorinated solvents. While in agriculture purposes, we know that that is a organochlorine phosphate or organochloride phosphate, organic organic phosphate fertilizer. Then we have also certain herbicides, fungicides, rodenticides, insecticides, and so on in agricultural pollutants. So basically, that will come with agricultural runoff when we're irrigating or whenever the certain conditions like runoff from the precipitation. Then emerging organic pollutants, so that are basically certain pharmaceuticals, certain personal care products, then endocrine disrupting compounds like bisphenol A and phthalates, then perfluorinated compounds, so that is basically known as PFAS, that are also dangerous for surface water and groundwater. So uh, that scientists ultimately focusing on its research currently. And then finally we have microplastics and plasticizers. Then certain petroleum and fuel-based pollutants like petroleum hydrocarbons, volatile organic compounds, and some certain natural organic pollutants. So finally, we have by after introducing source of fundamental emerging organic pollutants, we have introduced certain processes that affecting its dissipation and of organic soil, right? So basically, it's dissipation in organic soil or general soil. So there are total six processes that fundamentally involved in its dissipation. So first and foremost is sorption and desorption. So sorption is basically tells about the binding of chemicals or detachment of chemicals to the soil particles that ultimately affects its mobility. Then we have biodegradation. So biodegradation, it's tells about the breakdown of emerging organic contaminants by microorganism, and that's ultimately influenced by soil pH, moisture, and organic matter. That all the properties we have talked about in earlier lectures. Then also we have photodegradation. That's talk about the breakdown of EOC by sunlight. Volatilization, so it is a loss of gaseous emission to the atmosphere. Leaching involves that related to the groundwater. And plant uptake, so that is absorption by crops of that eosis. And let's also start about the summary week summary of week number 10. So in week number 10 we have started our lecture with the remediation of organic pollutants. So once we have identified source, so its source is either it's from industries, agricultural runoff, mining activities, or certain waste processing activities that is happening. So we have so after talking its all aspects uh, once the soil pollution will happen, what we need to do, right? So once it got happened, what we can do, so we need to protect it, prevent it, remediate it after its pollution. So there are certain techniques involved in it. So in that, basically in lecture 40, no, lecture number 46, we have talked about. So we know that it is very fundamental, right? It is very fundamental rights of anyone to get fresh soil, fresh water, or fresh any natural resources. And that's why it is very important to remediate it for our long-term sustainable development. So there are various methods that are currently applied in treating the contaminated soil and water. However, many of them are traditional in nature, right? Such as physical, chemical, and thermal that we'll basically talk about in upcoming lectures or upcoming slides. We'll also talk about the phytoremediation or bioremediation. That is an emerging technique. So after evolvement of, if you can see this figure, right? So in this figure highlights the evolvement of the various approaches to manage waste. So in around 1970s and 1990, the waste managed processing will start with landfill. Hi, Abhinaya. Yeah. So if you can see this figure, that evolvement of various waste processing technologies, specifically of the organic pollutants. So in early 1970s and 90s, we have we have only options such as landfill, right? So why landfill? Because at that time the contaminated soil was considered as the hazardous waste. Okay, so basically we are equating contaminated soil with the waste. We are not seeing as this contaminated soil as a resource. Okay, we can reuse it. So at that time, generally we are seeing that as a waste. So ultimately, what they are doing, they are just uh, putting that soil into the landfill area. Okay, and dispose it. However, that dispose after that it's disposed, they are considering okay that is the solution. But no, that landfill area also contribute again to the soil pollution or other pollution like pollution to the surface water resources or pollution of groundwater resources by leaching it through landfill area. So due to that, there are when the research grown or when the concept evolved of the sustainability, the scientists introduced a topic like green sustainable remediation and sustainable resilient remediation. So if you can see benefit of all of this, like if, for example, for landfill, there is a no impact considered, right? Because if there is uh, a certain area where the people are living and there are also landfill, so whatever landfill or waste we are putting there, that ultimately impacting the uh, the human or ecology available nearby this landfill. Because if you know that the whatever contaminant is there in nature, if it is in excess. Okay, so suppose we have this system. Okay, suppose this is one village and here is a landfill area. So if we are putting some waste here, so that waste we know that that waste contain various contaminants, either it is inorganic or organic. So if based on its property, what will happen? It will either volatilize, it will get down through the various processes like sorption, desorption into the groundwater. Also, it will uh, contaminate the other surface water resources like lakes and ponds that is available in that village. Also, imagine this side or in this village, peoples are living. Okay, so these people ultimately drinking this water right through groundwater or from pond or lakes, right? So what will happen? Due to the presence of this contaminant in this water, the people will get due to this water have a contaminants beyond the limit of beyond the limit of that will cause some health issues. Okay, so due to that, once the people will drink this water, so that ultimately cause certain impact on the human, as well as whenever this water will leach or come down to the surface runoff to these lakes, what will happen? The ecosystem like fish or certain water species that is available in these lakes, that will also get damaged. Okay, and if imagine there are certain agricultural areas here, and if and what will happen if you know the hydrological cycle? It is not like that. If the water is coming or water, once water will go at the bottom, it will not travel this side or this side. Okay, it will go either this side or this side based on the natural gradient. Okay, so due to that, if there is a condition like over extraction or over extraction of aquifer, due to that, what will happen if some farmers is extracting water from here, right? So what will happen, this water level will go down here, okay, as compared to here. So due to that, what will happen, there is a natural gradient will form, and that will ultimately mobilize this contaminant beneath this landfill area towards this well. And after that, if that farmer extract that water and irrigate the agricultural crop, obviously, right? And what will happen due to that, if that irrigated water will supply to some crop, so that contaminated water or emerging organic contaminants that available in this water, that will ultimately accumulate in the plant species, and over the time that limit also gets above the certain health standard, and that's how it is impacting our resource, our ecosystem and human health. So that's why consideration of green and sustainable remediation technologies or sustainable resilient remediation technologies are necessary. So here you can see the impacts that we are considering in our emerging technologies. So, so some traditional technology like physical, chemical, and biological method, that is considering some only primary impact. Like so, basically, it only talks about the primary impacts, means we are only aiming towards removal of that contaminant. Okay, while secondary means we are looking towards the societal factor. Okay, so basically, we are talking about some economics of the certain technologies based on the local condition, right? And in tertiary also, like similar to socializing impact, like what is happening due to this technology, like how or what cost we are adding, right? By introducing certain green and sustainable remediation technology. And finally, if you can see this sustainable resilient remediation. So resilient, whenever the word resilient come into the picture, it means it is related to the climate change. So it means you know that nowadays there is lots of extreme events that is happening, like either it is a flood, droughts, or heat waves. You can name any extreme events. So that is primarily due to the climate change. So that also we need to take care of in the developing technologies. So you can see this after 2010, scientists are trying to integrate this solution remediation technologies with the climate change. So whatever technologies will develop, that is either that is a sustainable and that will long lasting. So we are not harming our nature in long term. So yeah, so one important concept is the life cycle assessment, that is also nowadays people are working. So it is basically integrated quantitative method, okay, to quantify the environmental impacts associated with the remediation technique. And these generally we are considering secondary impact of contamination, right? And if we can understand through its one example, so LC allows quantifying the material and energy consumption and emissions from the site characterization phase to final treatment of any waste produced by remediation process, right? As I highlighted that it's all also considering the cost and economic factor, also energy consumption in treating of particular waste. So ultimately, you can see this comparison. So main core element of the best management practices for green remediation technology. Okay. So basically in terms of energy use, or there is a greenhouse gas emissions, air pollutant emission, water reuse, then waste production and soil habitat and disturbance. So it all gets minimized if we are implementing green and sustainable remediation technology. However, it's also maximizing use of renewable energy, energy efficiency, waste reuse, and materials management. Okay, and here are certain conservation and protection uh, parameters that it is focusing on. That's why it is very important to consider sustainable resilient remediation technology development as well as its implementation for long-term sustainability. Then, in continue with this lecture, we have talk about various physical and chemical methods. So generally, we have classified them as ex situ and in situ treatment. So ex situ basically involved at a field, right? So generally, we are doing certain uh, operations, remediation operation uh, in the laboratory by taking certain samples at the lab. Okay, while in situ treatment use the same process as ex situ, but it reduce the excavation and transportation cost as it only treating on site. Sorry. So that's why it is very important to choose the method. Okay, either it is a in situ or ex situ based on the local hydrogeological condition as well as contaminant present there. And then we have introduced certain surfactants and organoclays. So we know that surfactants are compounds that lower the surface tension, right, between two liquids. So basically, it will you can compare the surfactants and organoclays. So nature of surfactants are amphiphilic. Okay, amphiphilic means it is a hydrophobic and hydrophilic in nature. So hydrophobic means it is repelling water, but it is attracting the water. So that will help us to get emerging organic contaminants mobilize and solubilize. So after once it will become mobilized and solubilized, we can flush or remove them using certain practices. However, in case of organoclays, so it is basically modified clays, okay, and it have the property of a higher cation exchange capacity. So due to that, it will have the mechanism of the adsorption and immobilization. So it what it is doing. So so generally after surfactants we are using organoclays we are applying. So what will happen? Whatever emerging organic contaminants get mobilized or solubilized, so that will get absorb on organoclays. So ultimately that will become immobilized. Okay. Then we have also understood the concept related to the bio stimulation and bio augmentation. So that will also will talk in detail, and will solve question related to it in upcoming slides. Then as I already talked that why surfactants and organoclays are important in remediation. So that will help us to address non-polar and persistent organic pollutants. It generally useful in situ as well as in ex situ treatment. So it enhance the bioavailability of the contaminants for bioremediation or chemical treatments that help in meeting environmental standards by reducing contamination level. Then we have started learning about the phytoremediation. So phytoremediation, we know that generally we are using plants to eliminate or degrade the pollutants. Phytoremediation helps that stabilize the pollutants and prevent it to ready for the movement. And its mechanism, if we can talk about total five mechanism, uh, five main mechanism. Yeah, obviously, under this the subcategories are also available, but here we will also only talk about main mechanism. So first is a phyto extraction. So phyto extraction, in that plant absorb heavy metal or pollutants through roots and accumulate them in a harvestable plant parts. Okay, so certain species are listed here like Parasica. So it is generally suitable for heavy metals like lead, cadmium, zinc, and nickel. While phytostabilization, so plants immobilize contaminants in the root zone, and that will help us to reducing of its leaching. And it's often used for mine tailings and metal contaminated soil. And third one we have phytodegradation. So plants break down organic pollutants using enzymes within the root zone only. Then phytovolatilization. So plants absorb pollutants and release them into the atmosphere in volatile form and needs careful management due to the air quality concern. And rhizodegradation, so it is the rhizosphere biodegradation. So plant roots release excludes that simulates microbial activity in the rhizosphere, accelerating the pollutant background. Okay, so you can see that what we are doing, we are growing certain plant species in the polluted soil, so that that plant species, certain plant species that will help us either to extract it through that polluted soil. Okay, so that phyto extraction. So plant absorb heavy metals or pollutant. Then phytostabilization. So that stabilization means it gets immobilized and that will ultimately reducing the leaching. Then phytodegradation. So it will also degrade the emerging organic contaminant that is available in polluted soil by breaking it down into the organic pollutant. And phytovolatilization, so it is related to the atmosphere, so it will also get or release them into the atmosphere uh, through its crop cycle or plant cycle. And rhizodegradation, so it is related to the root zone activity, and in that generally uh, rhizosphere biodegradation is happening. And now after that, if we can talk about the effect of aging, so that also we have discussed during lecture number 47. So aging is basically refers to the physical, chemical, and biological changes that contaminants undergo after being introduced into the soil over time. Okay, so you know that once we are introducing some contaminant in the soil, so it will goes under various physical, chemical, and biological changes. Okay, and these changes reduce their mobility and bioavailability, even if the total concentration remains unchanged. So, due to the various physical, chemical, and biological activities of that particular pollutants, what is happening? There is a reduction in its mobility as well as bioavailability. So let's understand the bioavailability and total concentration. So generally total concentration refers to the entire amount of contaminant present in the soil, where bioavailability is the fraction of that is accessible to living organisms such as plants, microbes, and animals. And generally this bioavailable material or bioavailable soil contaminants are harmful and toxic in nature for plant. That's why we are generally considering the bioavailability during the remediation process. So we know that not all the contaminants need to be removed, and generally, if the contaminant is strongly bound and not bioavailable, it may pose minimal risk. Okay, the cost-effective decision that also we need to consider. So prioritizing contaminants with high bioavailability saves money and effort, right? But obvious. And third one is a risk-based soil remediation. So it focuses on the pollutants that actually threatening human health, plants, and groundwater. So by aging, we know that aging reduce the environmental risk by decreasing its bioavailability, and remediation strategy should focus on bioavailable fraction rather focusing on its total concentration. That will help us during the risk assessment and like how this contaminants affecting in the long term based on its bioavailable nature. And then with the continuation of previous lecture, we have started talking about the toxic inorganic substance. So inorganic substance basically don't have carbon in that. And in this lecture, we basically talk about what are the toxic inorganic substances, sources of these pollutants, accumulation in soil, some important toxic metal and toxic metals in sewage and sludge. So there are metals like arsenic, cadmium, chromium, copper, lead, mercury, nickel, and zinc that is available in nature as well as. But that if we are injecting that chemicals by some anthropogenic activities, then it will cause certain uh, harmful nature, like either it is impacting ecosystem or human health. So in this, basically, there are certain uh, chemicals is given, and what is its source is also provided. For example, for cadmium. So you can see the cadmium is basically coming from electroplating industries, then from pigments, plastic stabilizers, batteries, and high use of phosphate-based fertilizer. And this generally harm to every components like human, animal, fish, then birds and plants. And the disease to humans that is happening due to the excess of cadmium intake, that is heart and kidney disease, bone embedment, etc. Okay, so that's why it is very important to remediate the soil, either it is from inorganic contaminant or organic contaminant. So for that we have started learning about the remediation. So remediation is the process of removing or reversing this environmental damage, especially in case of soil contamination. And there are three major strategies that are highlighted. Okay, we have uh, identified during this lecture. So that is whenever you want to do remediation of particular soil, once first you need to identify its source and control that contaminant from its source. Okay, then what we can do, we can also do parallelly immobilization of that contaminants by making them less mobile and bioavailable using soil management such as pH adjustment or organic matter addition. Also, that we can also remove or decontaminant using various physical, chemical, and biological measures. Okay, for example, like whatever we have talked during application of surfactants and organoclays. Yeah, if you can see this figure, as I already talked about, there are various sources that from that this inorganic contaminants will come, like either it is from urban regions, industrial region, mining areas, or agricultural areas. So we continue to this. We have again go to the details, and then have talk about the problems due to the inorganic contaminants. So there is a problem like bioaccumulation and biomagnification in the food chain. So that will causing the uh, various hazardous effect. And there are certain bioremediation activities that will help us to fight with this inorganic pollutants. So there are plants that is varying their ability to tolerate, accumulate, and exclude heavy metals. So there are four category of plants. That is sensitive plant, indicator plants, excluder plants, and fourth one is hyper accumulator plants. So sensitive plants generally absorb metals but cannot tolerate them. Okay, and show growth inhabitation or die off. So due to that, it will get die, and it will generally useful as early indicator of contamination. So sensitive plants is generally that absorb the metal but it cannot tolerate them. While indicator based plants, so it uptakes metal that is proportional to the soil availability. It also survive across the range of concentration, do not accumulate excess metal, and generally useful for monitoring of contamination level. Then third one we have the excluder plants, so that tolerate the high concentration in restricting metal uptake or translocation, and metal remains in a root or bound to soil but not move to shoot. So it stabilize but do not remove the metal. Okay. While hyperaccumulator plants that actively extract and accumulate high metal concentration move metal to above ground tissue, enabling physical removals through harvesting. Okay, and can thrive in a highly contaminated soil, for example, brassica, alyssum, and thalaspi. So, in this from this slide, we have found that there are four plant species that we are generally using for different purposes. So first one is a sensitive plant. So sensitive plant is we are using as an early indicator, and there that can be dyed due to the heavy metal concentration. Then we have indicator plants. So indicator plants that relatively perform better, and generally we are using for monitoring of various emerging organic contaminants or inorganic contaminants. It's also survives in the range of concentration, but it not survive on excess concentration. Where excluder plants that tolerate the high concentration by restricting metal uptakes or translocation, while metal only remain in the root and bound to the soil. Where so we cannot remove or extract that pollutants, right, from the surface. While hyperaccumulator plants that actively extract and accumulate high metal concentration, it's also move the metal above ground tissue. So we can harvest that metal from the that particular field. Then we have started talking about the soil survey. Okay, soil survey. What is the soil survey? Its objective use of soil survey. Then basic steps involved in the soil survey and some mapping procedures and practical difficulties. So soil survey, we know that is a technique that provides information on the spatial distribution of soil and their variation. And there are certain questions we have and that we need to answer. For that, we need to carry out soil survey. And the question is what type of soil are present and what is what is its proportion. Then what is the type at any site of interest. Then where soil of particular type or particular range of properties be found. And then general objective of soil survey is fundamentally soil survey helps in gathering information about properties, its genesis, means its formation, then its classification and nomenclature of soil. All applied aspects of soil survey includes interpretation of soil data for use in agriculture, forestry, industrial, urban, and pastoral development. And we know that there are certain various applications the soil survey details. Sorry. So, a best example of using soil for agriculture or agronomist is to identify what kind of crop is suitable for this kind of soil, and also what kind of practices that we need to follow to uh, maintain the soil loss tolerance value. Okay, so this is the procedure of the soil survey. I'm not going into detail of that. And then we have talked about the concept of base map. So in that we have talked about cadastral map, topographical map, aerial photographs, and use of remote sensing. So cadastral maps on the scale of 1 gem 2640 to 1 gem 7920 in a plain area, and 1200 in a hilly areas are used for detailed mapping. So cadastral maps show field boundary and field or revenue survey number. However, they lack topographical details like contours and elevation. Okay. So basic purpose of cadastral map is only for revenue survey. It will contain the field boundaries. Okay, but it does not contain any information on elevation or contours. Then we have a topographical maps. So topographical maps are published on the scale of 1 gem 25,000, 1 gem 50,000, and 1 gem 2,50,000. These are used as a base map for various soil surveys in India. And topographical maps of physical feature contain details. It will provide the information of contours and elevation. While aerial photographs in a scale ranging from 1 gem 8,000 to 1 gem 60,000 are generally used in a different types of soil survey. Photographs contain 50 to 60% overlap, which is essential for stereoscopic viewing and stereo pads. Then we have talked about orders of soil service. So there are five orders, and each order have specific use, starting from intensive survey as a first order, followed by detailed survey, semi-detailed survey, reconnaissance survey, and uh, reconnaissance survey of order 5. But the major difference of the reconnaissance survey of order 4 and order 5 are survey scale and survey of mapping unit. So if you can see here, the scale for reconnaissance survey is generally 1 gem 2 lakh 5 50,000, 1 lakh, 1 gem 3 lakh. Okay. Also, yeah, it is up to 10 lakh. But the scale of mapping is higher in case of fifth order, and it's have its own use related to resource invention. Okay. When while if the base or unit size of mapping unit is higher, higher it means at a lower scale, like generally we can say it is on a hectare level, okay, or acre level. At that time, generally that we are using soil maps for a management. And as scales got increased, our main aim is to resource inventory, invitation. Okay, I'm sorry, not generally innovation of resources. Generally, we need to identify the resources. And then we also talk about the soil mapping units. So there are soil fields, soil complexes, soil borders, and these are the processes that we are following for the soil survey. So first process is the First step is the preliminary reconnaissance survey of the area, investigate the major soils and their pattern of occurrence. Then we are procuring the required base map like aerial photographs, satellite imagery, or topographic and other maps. Then preparation of mapping legend based on the preliminary field studies, and then stereographic study of aerial photographs. And fifth one is the soil are examined at some standard interval along with the traverse to locate the important difference in the soil properties, plotting of soil boundaries, and then we are classifying soil and mapping of naming of map based on the morphological, physical, and chemical properties. And then finally, we are preparing the final legend and finalize the soil map. Then there are certain examination description of soil profile, right? What are the data we are getting from from prepared map? So it is only about soil physical, chemical, and biological properties as well as its genesis. And then there are also certain practical difficulties in the soil survey. So that is related to the soil distribution. So generally distribution of the different soil may be complex. We know that. So soil or water also. So it is a very complex system. And even at a few meter distance, we can identify different soil behavior. Okay. So that is the problem. And that may occupy small area at the time of delineation of the map, and practical scale becomes difficult. Okay, so whenever we are extrapolating this small scale survey to the larger scale, so ultimately information gets diluted. It is also difficult to follow the geographic boundaries of the soil because the vegetative cover and hidden nature. Then soil survey and mapping are expensive, and may developing nations may not afford the as that are severe practical needs. Okay. Also, final the inaccessibility of certain areas because of transportation problem may restrict the number of sampling points. So that is the limitation. And then finally, in lecture number 50, we have talked about this remote sensing in the concept of soil survey. So certain models we have talk about. So basically, remote sensing is done technique that in that we are using certain radiation. Okay, and so we are using some radiation source such as a sun, or also we are uh, providing that rays, targeted wavelength rays from satellites. And then what we are doing that injected uh, rays will ultimately heat the earth's surface and will get reflect back. So whatever rays get reflected back, that we are interested in. So that reflectance ultimately provides a kind of feature available in the soil surface or earth surface. Okay. So these are the satellite pictures that have taken from the satellite, and all this principle will generally help us in the soil survey. Okay, so there are conceptual model in the soil formation, so that is provided by Jenny in 1941, and Scopan that is provided by McBratney in 2003. So this Scopan model is the fundamental and most commonly used model. And then generally, whenever we are dealing with the satellite data, we are identifying various indices that is related to vegetation, soil, water features, etc. that we have talked about. And then if I can specifically talk about the scope and model, so that means in this Scopan, in the Scopan, S means soil, C means climate, O means organisms, then R means relief, P means parent material, A means age, and N means location or coordinate. Okay, so all this we are using to map the soil survey or identify the soil formation. Then we have also talked about the NDVI concept. So we know that plant leaves contains chlorophyll which absorb visible radiation, that is the range of zero point 0.4 to zero point 0.7 micron. They reflect in a near infrared radiation, so that radiation get reflected at zero point 0.7 to 1.1 nanometer, and hence lushy vegetation can be differentiated from the dead aspects vegetation by observing near infrared peaks. Okay, and NDVI, normalized difference vegetation index, is used to find the relative abundance of vegetation. NDVI generally identified by NIR minus IR divided by NIR plus R, and it ranges from -1 to +1. And uh, uh, near infrared generally we are using for identifying dead vegetation, okay, species. And generally if the NDVI is higher, it means we have a denser vegetation or vice versa. So by using all this combination, we can identify the soil formation, and we can also carry out soil survey. And then we also talk about the digital elevation model and relief concept. And then we have ended up or summarized this lecture number 50 and overall week number 10. Okay, so that's it for week number 10. Uh, if you have any query till now, you can ask anyone. Hello. If you have any query, you can also write down into the chat box. Okay, so let's take here mm, 5 to 10 minutes break, and we'll rejoin. let's start problem solving session, that is MCQ. First question is surfactants role in soil is act as detergent, wetting agent, emulsifier. So we know that surfactants will act as a detergent, wetting agent, and emulsifier due to its hydrophobic and hydrophilic nature. So basically, hydrophilic means they attract the water, and hydrophobic it means it attracts the organic compounds. So correct answer is option D. Okay, sorry, D. All of the above. Right. Question number two. Which of the following statement is correct for distribution coefficient KD in a physical and chemical method of remediation of organic pollutants? So KD, we know that KD is provide distribution between soil and collected leachate sample. So option A, it is ratio of pollutant sorbed in soil to one present in a solution. So this is correct. It is a higher value of KD. More strongly pollutant is held by soil and the lesser it leaches. That is also correct. And organic matter rich soil and organoclays have a higher KD. That is also correct because we know that this organic clay rich and organoclays have higher cation exchange capacity. It means there are higher negative sides that ultimately attract this pollutants. Okay, so all of the above are correct. So option D is correct. Which of the following are example of toxic inorganic substance in soil? So inorganic substance, we know that all the heavy metals, that is starting from nickel, copper, chromium, zinc, lead, cadmium. So all of that are inorganic uh, toxic substance in soil. So correct answer is option D. Question 4. Introducing special microbes which degrade the pollutants more readily than the native population known as. So whenever we are introducing special microbes, we degrade the pollutants more readily than native population. That is known as bio augmentation. Right. Correct answer is option C. Let's also understand natural attenuation. So natural attenuation refers to the natural breakdown and transformation of pollutants, while biostimulation involves enhancing activity of native microbes by adding nutrients or substrates. Okay, like nitrogen and phosphorus. And bioaugmentation, that is related to the introduction of special selected or engineered microbial species, and that ultimately help us in remediation. Question number 5. How can we reduce arsenic toxicity? So by application of pesticides, application of sulfates of zinc, iron and aluminium, application of rock salt, and all of the above. We know that by applying sulfate of zinc, iron and aluminium, that help us to reduce the arsenic toxicity because these elements form insoluble arsenic complexes in soil. Okay, so by applying sulfates of zinc, iron and aluminium, that will help us to form insoluble arsenic complexes in the soil, and especially iron and aluminium sulfates are effective in binding arsenic, thereby reducing its bioavailability and mobility. Correct answer is option B. Question number 6. What does N stand for in the Scorpan model? So we know that in Scorpan, S stand for soil, C for C stand for climate, O stand for organisms, then R for relief, P for parent material, A for age, and N is for location. So N is for location. Option D is correct. Question number 7. The value of NDVI ranges between. So we know that NDVI generally lies between -1 to 1. Okay. And you can see this whenever the value of NDVI is -1, that says that a plant is in dead form. Okay. And whenever it is between 0.66 to 1, that is a very healthy plant. Whenever it is lies in between, that is either it is unhealthy or moderately healthy plant. So correct answer is -1 to 1, option D. Question number 8. Which of the following plant is more tolerant and resistant to toxic while simultaneously extracting the toxin from soil? So see, we have talked about four plant species of four type of plant during remediation lecture. So that is sensitive plant, indicator plant, excluder plants, and hyperaccumulator plant. So all these plants have their own benefits, and they have certain limitations. So generally sensitive plants we are using as a preliminary analysis, or as a we are using it for identifying the pollution is happening. Then indicator plant, that is we are using for monitoring purposes. Then excluder plants, so that is doing better than both this, but they not take this pollutants that is available in the soil to the surface, while hyperaccumulator plants takes this polluted or pollutants at the surface through this process. So that will we can also remove during harvesting. So the question is, the following plant is more tolerant and resistant to toxins while simultaneously extracting the toxins from the soil. So that is hyperaccumulative plants. Correct answer is option D. Question number 9. Remediation of soil organic pollutants can be achieved by bioremediation. Yes. Physical and chemical method. That is also we are using, and phytoremediation also we are using. So correct answer is option D. So basically bioremediation we are using certain microorganisms to break down that organic pollutants, while physical and chemical method we are using surfactants and organoclays. And again in phytoremediation there are certain methods that include like phytostabilization, phytoextraction, or rhizodegradation. So all of these are correct. What will be the value of bioaccumulation factor in the roots of excluder plants? So whenever bioaccumulation factor is less than 1, it means plant accumulates fewer toxins in the roots compared to the soil. This not typically for excluder plants, which limit the translocation to shoots but still concentrate in roots. Whenever it is greater than 1, so that is excluded plant absorb toxin into the roots but do not allow them to move to aerial parts. Hence, their bioaccumulation factor in roots is greater than 1, indicating efficient accumulation in the root relative to the soil. While when its value is 1, suggests equal concentration in soil, plant root and soil, and 0 means no uptake by root, which are incorrect. Okay, so what we need to identify, what will be the value of bioaccumulation factor in the root of excluder plants. Whenever there is excluder plant, In that condition, this factor is greater than 1. So correct answer is option. Question 11. Lushy vegetation can be differentiated from senescent vegetation by observing which of the following. So that is near infrared peaks, red peaks, UV peaks, or blue peaks. So we know that healthy lush vegetation reflects strongly in near infrared region due to the internal structure of plant leaves. So senescent, that is aging vegetation, shows reduced near infrared reflectance, making it this peaks key indicator for distinguishing. And correct answer is near infrared peaks. Which of the following is not category of the plant based on the response of accumulation of high concentration of metal in their root? So this question we have already, this concept we have talked about. So and here they are asking category that is not related to the plant based on a response of accumulation of high concentration of metals in their root. So sensitive plant generally not providing, or okay, sorry, the question is about the category that is based on the response to accumulation of high concentration, that is includer plant, right? Because includer plant does not recognize category based on metal accumulation behavior. Okay, while these are based on the accumulation of metals behavior. Question number 13. Which base map includes physical features and topographical details like contour, elevation, etc. So we know that topographical map, because cultural map we are only using for revenue purposes, or that generally contains boundary of the certain features but do not contain elevation and contours. So correct answer is option B. Right. While aerial photographs provide real images from above, which can show terrain, vegetation, man-made features, but do not inherently contain topographical like information like contour and elevations. Which order of soil survey is an intensive type of survey? So intensive type of survey, we know that whenever it is a first order survey, that is the most intensive types of soil survey, because it includes very detailed information that we are generally using for research farm and experimental plots, where accuracy is crucial and mapping scale is for first order surveys 1 gem 4000 or larger. Correct answer is option C. While second order survey, that's slight intensive. Okay. As order gets increased, the intensity or intensity nature become coarser. Question number 15. Plant leaves contain chlorophyll which absorb visible radiation. Range of visible radiation is, we know that whenever the range of this radiation is in between 0.4 to 4 to 0.7 microns. This range contains visible radiation, also known as a visible spectrum, and chlorophyll in plant leaves absorb light more strongly in this range. So whenever the light range will come from this wavelength, chlorophyll will get absorb this, and particularly blue, that is around 0.45 micron, and red around 0.65 micron wavelengths. So correct answer is option B. Question number 16. Which of the following statement is true about in situ and ex situ treatments of the contaminated soil. So in ex situ treatment is a cost effective and does not disturb the soil. Is it like that? No. What we are doing in ex situ, we are excavating that particular soil, contaminated soil, and we are transporting them to other regions. Ayashish.
Hi, sir.
Okay. So what we are doing in ex situ, yeah, we are extracting that contaminated soil and we are transporting them to other laboratory or certain research fields, and there we are doing its remediation. So in that we are disturbing the soil. So this is incorrect. In situ treatment involves moving the soil to treatment location. This is also incorrect. In situ treatment reduce the excavation and transportation costs. This is correct option, as we are treating that contaminated soil on that place only by using some physical, chemical and biological treatment methods. So correct answer is option C. Question number 17. What is the primary function of surfactant in soil or ground remediation? So we know that surfactants generally removes oils and hydrophobic contaminants like soil organic contaminants or emerging organic contaminants, because surfactants have properties of hydrophilic as well as hydrophobic nature. So hydrophilic, that will help us to extract the water, while hydrophobic, that will generally extract the organic pollutants. Separating that, the surfactants will help us to get these pollutants solubilized or become available to transfer it from that location to another location by using various materials like organoclays. So correct answer is option B. Question number 18. Which of the following compounds undergo natural attenuation through reductive dechlorination under anaerobic condition? So PC and TC. So PC, we know that there are a chlorinated solvent and undergo reductive dechlorination in anaerobic environments. Okay, and the process uses an electron acceptor and result in the formation of vinyl chloride and ethylene. So correct answer is option A, as well as in case of PCB also, you can see in the case of polychlorinated biphenyls that also degrade via reductive dechlorination in the anaerobic setting. So these both are the correct options. So correct answer is D. Question number 19. Why is soil spill cleanup slower in cooler and nutrient poor regions? So, due to the lack of nitrogen and phosphorus nutrient for oil degrading microbes, okay, that may be the reason. Low temperature, slow microbial activity, and chemical reaction. Okay, that's also fine. And oil is not sufficiently available to microbes for degradation. So, all of the above, this are the correct answer, right, for this question. Question number 20. What is the main mechanism involved in phytostabilization during phytoremediation? We know that plants uptake the during phytostabilization, the plants uptake and volatilize the pollutants. Okay, and that is generally referred to the volatilization, phytovolatilization, not phytostabilization. But in case of phytostabilization, plants stabilize the pollutants and prevent the movement. Okay, so this is the correct option. While plant converts the pollutants to nutrients, so this is not accurate and there are no process like that. And plant degrade the pollutants completely into harmless products, so that will come under phytodegradation. Okay, by certain bacteria. So correct answer is option B. Question number 21. What is the key feature of hyperaccumulator plants in phytoremediation? So we know that in hyperaccumulator plants, whenever you are using in a contaminated soil, so that will basically take the contaminants from the soil through roots, and that contaminants also gets traveled to the its leaves and fruits. So whenever we'll get harvest this plant, so that contaminant also get ultimately removed from the particular location. So they absorb only water from pollutants, so it's not incorrect. They accumulate contaminants in above ground tissue in high concentration. Right, this is the right. So they accumulate the contaminants in above ground tissue. So as you can see this, generally in hyperaccumulator plant, they are taking contaminants from below the soil and they are accumulating it on the surface. Correct answer is option. Question number 22. Why is the bioavailability more important than total concentration when deciding to the remediate contaminated soil? This is very important concept, right? Because whenever we are talking about total concentration, so total concentration either it is in the form of organic or inorganic form, and that it is not necessary that all the contaminant present in the soil that is harmful in nature to the plants, okay, or any human. So whenever there is the bioavailable nature of that particular pollutant, and whenever some certain contaminants is bioavailable in nature, that is generally harmful to the soil, some plant species, okay, and due to that, understanding the concept of bioavailability of that particular contaminant is important during remediation of the soil. Okay, so let's identify the correct option. Total concentration always reflects risk accurately. No, this is incorrect, right? Total concentration also involves the immobile, uh, immobile concentration, or that is not harmful concentration, or the concentration attached with the parent material that is not accounting risk accurately. While bioavailability indicates how easily contaminant can be absorbed or moved. So bioavailability, yes, this is the correct, right? Bioavailability indicates how easily contaminant can be absorbed or moved. That indicates ultimately the risk related to it. Well, third option, it seems to be right. Let's also explore other option. Age contaminants increase their total concentration over time. No, it is wrong because aging only just is aging is generally related to the become degradation of certain contaminants, but total concentration will remain unchanged. And remediation is easier when total concentration is higher. So this is also incorrect. Okay, we are generally not deciding remediation techniques based on total concentration. We are only selecting bioavailable concentration. Okay, correct answer is option. Question number 23. Which of the following groups includes toxic inorganic substance commonly found in soil? Okay, so that are all the heavy metals that are generally mercury, cadmium, lead, arsenic, nickel, copper, chromium, all that are inorganic toxic compounds. Option A is correct. Well, these are the we know that this is the fertilizer. Some of them are related to nitrogen, some are phosphorus. Well, this is the benzene tolerance related to the volatile organic compounds, and DDT, lindan and melathion is the pesticides that we are using in agricultural field. Question number 24. Why do toxic metal accumulate in the soil over time? So we know that that is generally due to they are biodegradable and break down slowly. Okay, they are converted into gaseous form and escape. No. They do not decompose and persist in nature. Yeah, right. That's why it is accumulating over the time. They are easily absorbed by plant nutrients. This is also incorrect. This is also incorrect. And from option A and B, correct answer is option C. They do not decompose and persist in soil. Okay. Generally, inorganic toxic metals are not biodegradable. They are decomposed. They do not decompose and they generally accumulate over time. So that accumulated metals generally also transfer to the plant cycle. Okay. Option C is incorrect. Question number 25. How do toxic elements accumulate in living tissue of animals and human? So, you know that by entering the food chain from soil to plant and plant to animal and plant to human. Okay, animal to human. So this is the cycle. So correct answer is option B. Which of which form of mercury poses greater risk to human and environmental health due to its solubility and bioaccumulation? So we know that elementary mercury is a metallic form and that is relatively stable and less available to biological organisms, but it can vaporize and pose a risk via inhalation. Inhalation. Okay. Inhalation means generally through during whenever we inhale the air through atmosphere. Inorganic mercury sulfide. So inorganic mercury sulfide are mostly insoluble and not readily available to plants or animals, thus posing minimal risk. Okay, this is correct. Methyl mercury is the organic and soluble form of mercury created by microbial action. It is easily absorbed by organism and bioaccumulates in the food chain, especially in fish and highly toxic humans. So this is the correct answer, option C, right? So relatively, methyl mercury is the most uh, vulnerable, most hazardous compound of mercury. Question number 27. Which of the following statements correctly describe the behavior of chromium in soil? We know that chromium 3 tends to form insoluble oxides and hydroxide at higher pH levels, making them less soluble, not more. While chromium 4, that is hexavalent form of chromium, is highly oxidized, more soluble in soil, especially above pH 5.5, and significantly toxic that posing severe health risk. So option B is correct. Chromium 4 is more toxic and soluble than chromium 3. Question number 28. Which of the following statement is true regarding heavy metal in sewage sludge? So only organic contaminants are present in sewage sludge. Not correct. Right. Uh, because it may also contain other inorganic contaminants. Heavy metal in sludge can enter the food chain via earthworms. That also. So correct option for question is option B. Question number 29. Which of the following is not recommended approach to reduce contamination through soil application? So there are various options like preventing pollution of industrial and vehicle emission, proper disposal of electronic waste to avoid toxic metal contamination, increased use of fertilizer pesticide to promote crop growth, controlled application of irrigation water and composted solid waste. So we need to identify here the statement or the practices that are not recommended approach to reduce contamination through soil. So preventing pollution is the right option. Proper disposal of electronic waste to avoid toxic metal contamination. That is also correct, right? Recommended approach. Increased use of fertilizer and pesticide to promote crop growth. That is incorrect option because we know that there are certain fertilizer and pesticides that contain heavy metal and that ultimately uh, if it gets over applied to the crop field, there is a uh, problem like accumulation of that heavy metal over the time, and ultimately that will come into the food cycle or environment, and that will generally harmful for ecosystem and human health. Question number 30. Which of the following correctly explains the fundamental and applied objectives of soil survey? So, fundamental and applied objective of soil survey is generally it is option C. So that is to understand the soil properties and interpreting them for agriculture development. Okay. Question number 31. Which of the following is the major practical difficulty encountered during soil surveys activity? So soil survey are not permitted in rural area. It's not like that. Soil disturbance may be too complex or fragmented to map accurately. It is maybe right. Let's check. Soil survey more only needs one sample for one region. So that is incorrect. Okay. Soil survey do not require any transport. That is also so option B is correct here. Okay, soil distribution may be too complex or fragmented to map accurately. Question number 32. Which of the following is not an advantage of remote sensing as described in figure? So provide a view of a larger region. So now that is the advantage. Offers georeference and digital information. That is also good. Depends on a clear weather to operate. Operates in every season and even in tough weather. So this is the incorrect option, right? Option D, so not an advantage of remote sensing. Okay, so this is option C is not advantage. Okay, it depends on clear weather to operate. So correct answer is option. Question number 33. Which of the following statement is true regarding soil identification using spectral difference? So this is option C is correct answer for this. Okay, as we have already discussed this concept NDVI and other near infrared red wavelength concept. I'm not going into details, so let's end up here. Before we wrap up our session, let me quickly recap the content we have covered. Before that, if you have any query, you can raise your hand, you can write into the chat box. Okay, if you do not have any query, let me quickly recap this session. So in this session, basically we have talked about remediation of soil organic, soil organic as well as soil organic inorganic pollutants, and then we have also introduced soil inorganic pollutants and how that generally impacting our natural system. Okay, then we have started talking about the soil survey. In that, we have learned concept related to remote sensing and GIS, and how we can use that concept in soil survey. So with that, let's end the session here. And I'm requesting again you to provide your valuable feedback through mm, this link that I provided here at the end of lecture material. So you can access this lecture material through this drive folder. Okay, so thank you so much for providing your valuable time and joining the session. I hope you find this session helpful for your coming NPTEL exam. So let's wrap up here and we'll meet in upcoming weeks. Thank you.